All right, so today we're going to talk about graphing square roots and cube root functions. So a radical function has a really complicated definition. It's a function with a radical. So for example, y equals the square root of x would be a radical function. All right, so first one we're going to talk about are square root functions. The parent function for a square root function would be f of x is equal to the square root of x. Since we're taking the square root, can we take the square root of negative numbers? No, we can't. And not get a real number anyway. We can only do it if we're dealing with imaginaries. But okay, so my domain is going to be that x is greater than or equal to 0 because I can't take the square root of a negative number. And because I'm taking a positive square root, my range will be that y is greater than or equal to 0 also. So I can just make myself a little table and graph it. And I'm just going to pick perfect squares to put in for my input so that I can get easy numbers to work with. You can use any number, but since we're not using calculators, it's easier to just stick with perfect squares. So 0, 1, 4, and 9. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So then when I go to plot those points, 0, 0, 1, 1, 4, 2, and 9, 3. And so this would be the graph of f of x equals the square root of x. All right, the next one we're going to do is the parent function for a cube root function. So my parent function is f of x equals the cube root of x. So on this one, my domain and range, is there a limit on what I can put in for x when I'm dealing with cube roots? Can I take the cube root of a negative? I can, right? Like the cube root of negative 27 is negative 3, right? Okay, so for this one, the domain and range are both going to be all real numbers, because we can have both positive and negative numbers on these. And so again, just choosing easy numbers to work with. I'm going to choose numbers I can take the cube root of. So negative 8, negative 1, 0, 1, and 8. And the cube root of negative 8 is negative 2. And the cube root of negative 1 is negative 1. And the cube root of 0 is cube root of 1, 1. And the cube root of 8, 2. All right, so if we graph those points, negative 8, negative 2. Oops. Yeah. And so the parent graph looks something like that for the cube root. All right, so for this one, what we're going to do is we're going to graph y equals 1/2 times the square root of x, and then we're going to state the domain and range, and then we're going to compare the graph with the parent graph of y equals the square root of x. So before I make my table, I should think about what my domain and range is anyway. Can I put in any negative numbers for this one? No, I can't. So my domain is going to be x is greater than or equal to 0. And it's a positive 1/2, so all my answers are going to be positive. So the range is also greater than or equal to 0. So y is greater than or equal to 0. So again, when I'm dealing with square root, it's easiest if you make your table using perfect squares. So 0, 1, 4, and 9. So what's the square root of 0? 0, and half of 0 is still 0. The square root of 1? 1. Half of that would be 1/2. And the square root of 4? 2, and half of 2 is 1. And the square root of 9 is 3, and half of that would be 1.5. And then you just plot the points. So 0, 0, 1, 1/2, 4, 1, and 9, 1.5. And then I'll go ahead and put the parent graph on the same graph so you can compare it. So does it look like it was compressed or it was stretched? It was compressed, right? It was pushed down. So it was compressed vertically. By a factor of what? By a factor of 1/2, yeah. Okay. Any questions there? All right, so now we are going to graph y equals -3 times the cube root of x, state the domain and range, and then compare the graph with the graph of y equals the cube root of x. So again, thinking about my domain and range, since it's a cube root, is there a limit on my x and y's? No, so it's still all real numbers for this one. So again, for my table, I chose perfect cubes, -8, -1, 0, 1, and 8. All right, so now I have the cube root of -8, which is, what's the cube root of -8? -2, but I've got to multiply it by -3. So -2 times -3 is +6. And then the cube root of -1 is -1. -1 times -3 is +3. And then we get 0, -3, and -6. And then you just plot the points. So -8, -6, -1, -8, +6, -1, +3, 0, 0, 1, -3, and 8, 6. So your graph ends up looking something like that. I missed my point. Oh well. All right, then I'll go ahead and put the parent graph on here so we can compare it. So if I think about whether it's stretched or compressed, which one do you guys think it is? This time it's stretched because it's going higher and lower, right? So it's stretched vertically. By a factor of 3. But what else happened to it besides it being stretched? It's flipped, right? Over the x-axis. So it's reflected across the x-axis. Okay. Any questions? All right, so when you're done copying that down, you still have some extra room on that graph paper. Do the same for y equals -1/2 times the cube root of x. Graph it and then compare it and let me know how it compares to the parent graph. And I'll come around and see how you guys are doing. Okay, so if we put in Well, first of all, our domain and range. What's our domain and range going to be? All real numbers. All right, so if I put in a -8, what do I end up getting out of it? A +1. And -1? +1/2. 0, 0, 1, -1/2, and 8, -1. So I go ahead and plot those points. It looked like most of you were getting this when you did it. All right, so how does it compare to my parent graph, which I already had there in pink? It's being reflected across the x-axis, yep. And yes, it's compressed by a factor of 1/2. All right, so just to make sure you guys remember, what is the domain for a square root function? X is greater than or equal to 0. And what is the range of a square root function? Y is greater than or equal to 0, if we're talking about the parent functions. And then what about my cube roots? All real numbers. All right.